Hello, pre-algebra students. This is Chapter 3.5, Solving Inequalities Using Multiplication and Division. In Lesson 3.4, we learned to solve inequalities using addition and subtraction. Today we'll tackle multiplication and division. Let's begin with the multiplication property of inequality. Let's use this inequality, 2 is less than 8, to illustrate the multiplication property. If we multiply each side of an inequality by a positive number, in this case, let's say 4 times 2, or 4 times 8, we produce an equivalent inequality. In this case, 8 is less than 32. However, if we multiply each side of an inequality by a negative number, for example, if we were to multiply 2 times negative 4 and 8 times negative 4, we do not get an equivalent inequality. This would give us negative 8 is less than negative 32. We know this is not true. In order to make the statement true, we have to reverse the direction of the inequality symbol. Let's work through it one more time, adding that step. Negative 4 times 2 would give us negative 8. 8 times negative 4 would give us negative 32. If we change the direction of the inequality symbol, now we have an equivalent inequality. Negative 8 is greater than negative 32. So to restate the rules, if we multiply each side of an inequality by a positive number, it produces an equivalent inequality. However, if we multiply each side of an inequality by a negative number, we must also reverse the direction of the inequality symbol to produce an equivalent inequality. Let's use what we've just learned about the multiplication property to solve for m. m divided by negative 3 is greater than 3. Our first step in solving this problem is to multiply each side of our inequality by negative 3. So I'm going to rewrite our equation, negative 3 times m over negative 3 is greater than 3 times negative 3. Because we are multiplying by a negative number, when I simplify to get m and negative 9, I have to change the direction of my inequality symbol. So m is less than negative 9. We can check to see if this is correct by putting 9 in for m, or excuse me, negative 9 in for m in our equation. If all of the values of m have to be less than negative 9, let's substitute in negative 12 for m. Negative 12 over negative 3 is greater than 3. Negative 12 divided by negative 3 would be 4, and yes, indeed, that is greater than 3. Let's do another check by adding a number we don't think is going to work in the set. So let's try negative 6. Negative 6 divided by negative 3 is greater than 3. Negative 6 divided by negative 3 would be 2, and 2 is not greater than 3. This is not a true statement. So I think we can guess with fair certainty that we've done our work correctly. m is less than negative 9. Now let's address the division property of inequality. We'll use the inequality 4 is less than 8 to illustrate this. Dividing each side of an inequality by a positive number produces an equivalent inequality. For example, let's divide each side by 2. That gives us an answer of 2 is less than 4. That is an equivalent inequality. However, if we multiply each side of an inequality by a negative number, do we get an equivalent inequality? Well, let's see. We get negative 2 is less than negative 4. Nope, not a true statement. Just as with multiplication, when we're dividing each side of our inequality by a negative number, we have to switch the direction of the inequality symbol. So let's try that here. 4 divided by negative 2 gives us negative 2. Switch the direction of the inequality. 8 divided by -2 gives us -4. Is -2 greater than -4? Yes, it is. So to clearly state the rules again, when you're dividing each side of an inequality by a positive number, you produce an equivalent inequality. However, if you're dividing each side of an inequality by a negative number, you must reverse the direction of the inequality symbol to produce an equivalent inequality. So multiplication and division in this case follow exactly the same set of rules. Let's use what we've just learned about the division property to solve this inequality. -10t is greater than or equal to 34. So we begin by dividing each side by -10. As we simplify, we'll also need to change the direction of our inequality symbol because we're dividing by a negative number. This will give us t is less than or equal to -3.4. Now try 4 of these inequalities on your own. Each requires you to use either division or multiplication to solve the inequality. Press pause, show your work in your homework notebook, and come back in a moment to write and solve an inequality of your own. Now let's put all the pieces together to write and solve an inequality. Some flocks of Canadian geese can fly nonstop for up to 16 hours. In that time, a flock can migrate as far as 848 miles. At what average speeds can such a flock fly during migration? Let's begin by writing a verbal model. Begin by recalling that distance equals rate times time. Therefore, we want to write our verbal model as flight time times the average flight speed will be less than or equal to our distance. Now, why did I use less than or equal here instead of an equal sign? That's because we're getting an average flight speed. So we can't necessarily say that our flight is always equal to this speed. It's going to be equal to that speed or less than, so that it will give us the correct average speed. Make sense? I hope so. Let's go ahead and fill in the numbers in this equation. Our time is 16 hours. Let's let S represent speed. And that's less than or equal to 848 miles, our distance. So we'll solve this equation by dividing each side by 16. Okay, I said equation, I should have said inequality. This will give us S being less than or equal to 53 miles per hour, which we'll write as MPH. So our flock of Canadian geese can fly an average speed of 53 miles per hour or less during a migration and still travel our 848 miles in 16 hours. That's all for today's lesson. When I see you tomorrow, we'll do some practice problems together to firm up this idea of using multiplication and division to solve for inequalities.